This video is produced for students enrolled in the EPO 322 Diesel Engineering 2 simulation course held at Cal Maritime. This tutorial will cover all the engineering procedures required to successfully complete Lesson 2 using the Kongsberg Diesel Simulator. This video is the second of a two-part series. As a brief recap of where we are and where we're starting out in Lesson 2 and our goals, Lesson 2 carries on directly from Lesson 1. The SSDG is supplying power to the main and emergency switchboards. The saltwater and low-temp freshwater cooling systems are operational. The potable water system is up and running. The starting air and service air systems are lined up and functional. In this exercise, we will be lighting off the oil-fired boiler to provide steam to the heating services. And the boiler is a large, modern D-type boiler capable of producing 30,000 kilograms per hour of superheated steam. To prevent thermal stress to the boiler, it will take 4 hours to raise steam to full pressure. You should see no steam pressure rise at all within the first hour, so we don't expect to see any pressure rise during this scenario. If you were to see steam development in the boiler drum, you would need to immediately shut the fires out until an hour is eclipsed from the start of the warming up process. The reason this is such a large boiler, it's required to run the following steam turbines in addition to plant heating services: main cargo pumps, ballast pump, steam turbine electrical generator. So we're starting the boiler up to provide heating services to the plant, because this is what is going to take the longest as far as getting this plant ready to go out to sea. It's going to take quite a while to heat up our fuel tanks, lube oil tanks, heat up the main engine, etc. So in Lesson 2, we are first going to light off the boiler on marine diesel oil. Then we're going to line up salt water to the main condenser, supply heating steam to services, which includes the fuel oil storage, fuel oil settling, fuel oil service tanks, main engine high temperature fresh water heat exchanger, and lube oil separator heater to get the main engine hot. Atmospheric drain tank. We'll also start heating that. We want to prepare the domestic refrigeration system for operation. This is not a refrigeration course, but we will go through the steps to get that system operational and start pulling the box temps down. We'll properly configure the power management system with SSDG number 1 in service and SSDG number 2 in standby. We will again start heating the main engine by heating jacket water to the main engine with the HT high temperature fresh water and the lubricating oil. And we will place the sewage system in service. All right, so I'll go ahead and start it. The first thing we're going to do is put on the what are we going to need? Well, we're going to be getting the high temperature fresh water system ready, and we're not going to use these pumps per se, but I want that system operational and ready to go when we're finished. So we'll put power to the main high temperature fresh water pumps, the exhaust boiler circ pumps, exhaust boiler compression air, combustion air fan, heavy fuel oil, diesel oil pump, all of those, main feed water, auxiliary feed water. These are all off the starters. And then let's go ahead and get our refrigeration plant, sewage treatment. We're going to need the lube oil purifier, the condensate vacuum, condenser vacuum pumps, main condensate, auxiliary condensate. That's enough on here. And we'll go over here and we're going to need the auxiliary high temp fresh water on the emergency switchboard. So the first thing we're going to do is let's go look at our steam generation plant. We got to get this boiler level in line, and we got to line up our valves. So we'll go to oil-fired boiler. Very important, open the superheater vent. Again though, don't think that will protect you on initial light off, because there's no steam being produced, and there shouldn't be any steam being produced in the first hour. We'll go ahead and open our air cock, and this you would close once steam is pressure is raised and you see steam coming out of this vent. You can go ahead and close it the air cock is there so that that steam will push out any atmosphere within the steam drum, so that O2 does not get included into your boiler water. We're going to open our desuperheated steam stop 100%. I want to produce, once this is producing steam, I want it going out to the system. That will put a little bit of load on the boiler. Again, I want to bring this boiler pressure up slow. I don't want to bring it up fast. And it'll also warm up all the steam systems and start bringing back the liquids, and it'll prevent water hammer. So we want our desuperheated steam stop wide open. We need to open for the circ pumps. Their suction from the mud drum return back to the steam drum. All right, we've got that. Now we got to put some boiler water in there, and I'm going to start filling the feed water tank. This is too low, and we're going to fill that to above 1 meter. So we'll start that up. While I'm here too, I'm also going to open up the steam valve to the feed water tank. Again, we're lining up systems ready to go. So we want the small one, and you see down here, the upper one is the small. We need to open up our feed stops, both the main and the auxiliary. This is too much on the filling. It'll come up too fast. So we're going to drop that down to about 25%. And we're going to go ahead and start up the feed pump. And we're going to watch our level. Now, right now, this is in millimeters. 0, again here on the level indicator, 0 is mid-drum. Minus numbers are number of millimeters below the mid-level. Positive numbers are above. And we're going to try to get this stopped at around a -50. And that's about 2 knots low. In other words, that's low enough that as we start heating up this boiler, I'm going to worry about the swell, or swell causing this, as we develop those steam bubbles, raising up the boiler water level too much. So my level in the beginning is going to rise. So we want it slightly low on light off. Now, normally where I stop is about 60, and then just right now, go ahead and shut it down. It'll drift up, and you'll see it drift up a bit. Now, once that's done, we can go ahead and put the level controller in auto, and we'll leave it the set point at mid-drum with the feed pump on. We're not producing any steam right now, right? And if I leave this on, there's always a small amount of leakage past that feed water regulating valve. So a small amount of water would be going into that drum, and it would be drifting the level up. And what you would find in real life, we've seen this happen multiple times, where they leave that on and your level gets up and you trip on high level. So leave it off until this starts producing steam. Once the boiler water level starts coming down, you get below mid-drum, and go ahead and put it back on again. All right. So now that boiler is ready to go. We've got the proper valves open. Oh, by the way, too, on this steam drum, on the desuperheated steam drain, you would typically leave that open so that any water coming back, you would drain it out, and then once you've drained out your water, you're going to go ahead and close that. We're not going to run the circ pumps. We have no waste heat. We're not going to be running that system, but again, on the initial lineup of this boiler, I would open the inlet and a return to prevent us from forgetting those as we move down through the exercises. All right, so we're ready to light. Let's line up our fuel. Go to your fuel oil service tanks. Line up diesel to the boiler. And this three-way valve, we need to select to diesel. Make sure you don't forget that you want to be on diesel oil. You'll see we get this low atomizing pressure. That's because we have no steam atomization pressure right now. We'll talk more about that. We'll have to clear that before we move on, though. I'm going to start up my boiler forced draft fan. This is the forced draft fan damper control. I'm going to go ahead and open that up 100% because I'm going to go do a purge. Okay. So this is just telling me that it's tripped, and the alarm mask was released when I started up that blower. These are your dampers. You have this a top fired boiler with two burners. That black box represents a closed register. We'll go ahead and hit start. You'll see those open. You'll see the flow rate come out. We're purging. Now, we're going to need atomizing air, which is coming down here off the ship service air system. So, well, this is their control air. Anyway, the Europeans like that. I certainly don't. Let's go back. We have to use air because we have no steam. Now, don't forget the three-way valve, and this is coming from your air. We can go ahead now and reset that trip. And that disappeared. Okay, so we're good. We've done our purge. Now, go ahead and bring your damper down to about 9%. And then watch your damper drop down here. By the way, this will not go below 3%. It will never close the dampers all the way to try to maintain a fire. On your firing rate, we'll set initially at 15%. Now, any boiler that you go to, you're going to have to play with the settings. But about 15% firing rate for startup is a pretty good average. And what we're trying to do is raise the firing rate up a little bit so that initially we can guarantee that, or not guarantee, but we hope that flame will establish. If we try to start out a very, very minimalistic, there's a good chance it wouldn't light. Now, one of the advantages we have with this system is this has a pilot diesel oil pump that will pump oil through this, and then you have a second small little burner here that has a spark igniter, and it ignites a small diesel flame that's used to ignite the main fire. Much better system than when you're trying to ignite the main body of the fire with an igniter like you do on a typical oil-fired boiler, say the one that we have on our steam sim. But anyway, we'll go ahead and start our diesel oil pump up. I did open up the fuel. So we'll go ahead and start that up. I've got 15% on, this is my fuel oil regulating valve, about 9%, right, on my forced draft fan damper. That should light. Pilot comes on and ignites the pilot flame, and then you'll see the main valve open and ignite the main fire, and then this will go out again. Okay. Now, once we have a good fire, we want to make sure that we don't smoke. And part of that is don't go below 2% oxygen here. Now, this, you can read oxygen here, but also here. That's the flue gas, boiler flue gas oxygen content. So, but this firing rate would give us steam within about 30 minutes, and we can't have that. So we have to drop that down. So we're going to drop this down to a minimal. In other words, where this damper is basically closed, and do it in steps. And I'll try 12, and let's try 6 here. I'm trying to keep this air fuel rate from going up too much or down too much. And let's try 7 here, and let's go 3. So that damper is basically closed. It's going down as low as it can. And my air fuel rate's coming down. This won't indicate, this meter won't indicate till that gets below 5. We seem to have a stable flame. And I'm settling out somewhere around 3 or 4. Right now it's at 4% oxygen. Perfect. We've got a stable flame. We can now move on. Okay, so from here, I'm going to line up salt water to that main condenser. So the main condenser comes off the saltwater system here. And then we're just opening it 10%, just a small amount of water. All right, and again, we shouldn't need this. If everyone's being attentive, it's a non-issue. Now the one thing when I look at this hot well and I see that the level in the hot well is all the way at the top of the glass, I'm going to pump that down. I don't know if there's a level up into the condenser. So we're going to start up, and I use the bigger pump because we just want to pump it down. And we're going to pump that down into about a mid-glass. One thing realizing on this too, this unit uses vacuum pumps rather than an air ejector. So we're not really worried about using the hot water in the hot well, condensate in the hot well as a coolant. So we could pump that even dry if we wish to, but there's no reason to. And then by the way, you notice that this is a small amount is led back as a reserve. Okay, so next thing we're going to do is we're going to supply heating steam to all the different services. So as that boiler starts producing steam, it's going to start going out there and do its heating. So we've got these 2 bunker tanks that we need to heat up. We're going to open up the supply to them at 100% right now. They're only at about 30 degrees C, so we cannot pump oil. This is too cold to even pump it. We could not transfer pump oil right now, so we need to start heating that. Then we'll work our way down. We went from transfer system, let's go to settling. These set points are already given to you. But one of the things I want you to note is 65C. The minimum flash point of marine fuels is 60. So technically, you may be even at this low set point, at 65C, the vents coming off of this, technically if you put a lighter beside it, you could get a flame. So something to think about. So we're going to heat both of these tanks to 65, and that's a pretty normal temperature. Now in your storage tanks, if we go back, in these tanks, you would not really want to get above 50 because you don't want to produce that much vapor coming out of those tanks. But relatively, in your settling tanks, it's there for a much shorter period of time. All right, from the settlers, we will now go to our service tanks. And we'll put the steam on both the heavy and the diesel. Again, the set point here is 65, though I see people running this up to about 80. And again, think on how much vapor you're producing. They do it because some of the modern fuels, it puts a lot of load on your fuel oil heaters for the main fuel system. All right, so we've got that. Now the next thing we're going to do is we're going to go to that refrigeration system, and it's fairly simple to put on. All right, first thing I'm going to do is, this is the vent. This vents the main condenser down to the receiver, and then this is the drop. This is the liquid from the condenser going down to the receiver. Both of those have to be open. We're going to open up the salt water, cooling water line to the lube oil cooler, and also that goes to the condenser and start a saltwater pump. We need to put on each of our diffusers. And then when we come back, make sure and put this lube oil circ pump on. That has to be on. And we don't want to put too much load on this compressor on startup. So I leave it in manual and I put it in about 25%. All right. Once we start the lube oil pump, our trips should all clear here. And we can go ahead and start it. Now, what I'm doing initially, that's 3 bar suction pressure. Now that's 45 pounds. I would be worried about about any liquids that had formed in this system while it was shut down, and the possibility of liquid slugging back. So in the beginning, I'm not going to put any liquid on. I'm going to wait till this drops down to about 1 bar, and then I'll go ahead and put the system in automatic. So we've got a right now we've got about 1.7 bar suction pressure and 8 bar discharge pressure. And again, that high pressure coming into the condenser, what that's doing for you is raising its saturation temperature above the saltwater temperature so we can condense it. All right, we're down to 1 bar. I'm going to go ahead and put the liquid on and go ahead and put the control in automatic. And it should run itself. Now we will probably get an alarm on this provisional store box, which is fine. What's going on with this is until the system cools down and stabilizes, we'll get a few alarms. We can see some liquid starting to build up in the condenser, and it's flowing out of the receiver into the system. Now, this overload protection, you saw that became active. We're limiting the output, power output, to about 50 kW. And initially it tends to come up a little bit and then stabilize. So we're good there. All right, that's all there is to it. Now, on the power management, here's the alarm I'm talking about. And it's refrigeration provisional store vat pressure, and it's high. That's fine for right now. The temperatures have to stabilize. It's picking up so much heat. All right, so we're good. So we got to properly configure the power management system. So we'll go to Power Chief Computer Control, Generator Control. This is what we're going to set up. Now you notice neither one right now has a ready light. To get that ready light, we have to go ahead and put the engine control in remote. Now, and actually I'll go back for a second. You'll see I got the ready light here. On generator 2, we do also have to put it in remote, but we also have to set up its voltage regulator. So go to diesel generator number 2, put your automatic voltage regulator on, and adjust it to about 50%. And same as what I'm doing is that adjusting it the same as number 1, hoping that when it starts, its voltage output will be good. All right. Now, if we go back up to generator control, I have a ready light on both. This is my primary. I want to put it priority 1, the other one priority 2, and put them both in auto. Never leave just one generator in auto. That means nothing will happen. It can't control. By the way, and what I did is I just clicked on the Power Chief load diagram. This is the power management system. It shows you which generators, the green box shows you which ones are active, being controlled. If that yellow, which is the load on the generator, comes up and gets in near the red, what will happen is you'll see this generator required. You'll see it automatically start generator number 2. It will parallel it, or it will synchronize it with the generator on the line, and it will place it on the line and balance the load. And then if the load dropped down to where with both of them on, one of them got down into the green, it would automatically disconnect that generator and then stop it. All right, so let's start heating the main engine. We need to go to our fresh water system. I am going to open the high temperature fresh water to the preheat heat exchanger inlet to the engine. Don't forget this is your vent outlet. Your set point is ADC. Go ahead and put it in auto. The bypass around your evaporator needs to be open 100%. We can go ahead and start that auxiliary pump. Wait until you have a flow. and then go ahead and put our steam on. Next, we'll go to the lube oil, main engine lube oil. Oh, let's go back actually, steam generation plant. I got that a little high. That's still normal, so we're okay. Normally they'll shut it off a little earlier, typically after you pump down the condenser. Okay. Low temperature on the high temp, and of course that is going to be true, right? You'll also get a low pressure and you get a low temp. We're only running the auxiliary pump. This is, think about it, this is the same as the keep warms on the Bear, a much smaller pump just to circulate water, and what we are doing is we're going to be heating up the main engine system. All right, so let's go back to lube oil. We're going to line up to the lube oil separator. We're going to set its, we can go ahead and start the pump up, and we're going to set its variable speed drive for 25%. Wait until we get a flow, and then we're going to go ahead and use a set point of 85C. We're going to put the temperature controller in automatic and go ahead and put on the steam. So what we're doing is we're now, and you can see the flow from and back, we'll be using that to heat up the main engine sump. To place the sewage system in service, here we go. All right, the first thing we're going to do is start one of the aeration tanks. Go ahead and put it in auto. This is not very different from the system on the Bear. This is where all your sewage comes in with the solids, and then from here it is drawn from this tank into the settling tank, and of course you have microbes that are eating it, and then the liquids are drawn off and go to the into this chlorination tank, which is your treated water, and it's chlorinated, and then that's going to be pumped over the side. Any solids floating on the top are going to be skimmed out and returned back to the aeration tank. And again, this is where, and you've got an air diffuser at the bottom. This is where most of the breakdown of that solid material is going to happen, and you're moving the solids. Okay. So then we'll open up the suction from the aeration, the chlorination tank. We need to open up this bypass, open up, and this is electronically controlled as when we put this in automatic. Then we'll go ahead and open the pump discharge. We have 5 minutes to complete the scenario. Set this at about 40% rate. We'll put the overboard open, and then we're going to put one of the pumps in automatic, and it'll start up and put our UV light on. And then what it will start to do is pump that over the side. You will get this alarm, which is the overboard flow, biochemical oxygen demand. Yeah, that's until it settles out. Sorry. All right. And then what happens is, you can see this is where it starts the pump. This is where it shuts the pump off. And if it gets up to a high level, it will open the bypass if needed to bring the level down. So the sewage treatment is now up and operational. All right, so what I'm doing right now, and I'll let that run while we're talking, so I can bring over the assessment. All right, the only green that we don't have is we have to run the simulator for 29 minutes. So we've got a 91% score right now. So we've scored above the 70% minimum. We have met all our critical achievements. We have no critical errors. You can see I have no reds. no negative assessment points. So what are the critical achievements? You have to have the boiler firing on distillate. You have to be circulating the high temperature fresh water system. The circulating lube oil to the sump. You're heating the main engine lube oil. Because again, those were the two majors here. You want to have the boiler getting ready to fire. And we want to be heating the main engine. You have to have the refrigeration system running. What will cause a critical error? Trip the boiler, and this is basically a low level. Trip the boiler on a high. Boiler pressure rise excessive. In other words, you haven't dropped down to a minimal firing rate. You have to drop down to a minimal firing rate because you would damage this boiler if you didn't. Firing this boiler with the superheater vent closed. Again, we're worried about that superheater vent. Even though in the beginning like this it would not physically hurt it because you're not producing steam. It's still protocol. Any chief engineer that I know about there would have your guts for garters if you lit off this boiler without opening the superheater vent. So we're at 28 minutes. All right, so you will get, when you run this with the eCoach, you will get a tag telling you when the lesson 2 is successfully completed. So you know if you've done everything right when you are practicing, even if you don't have this assessment editor available to you. And this is looking at the boiler tripping, the boiler smoking, boiler level not within limits. There's no reason to run the exhaust gas boiler circulating pumps. Your superheater stop, why are you opening that up? Superheater light off with the desuperheated steam stop closed. Boiler firing rate excessive steam condenser. All right, so I now have 29 minutes. So I've gotten green there. And everything is met. So all greens, no reds. I'll go ahead and halt it. And I've been talking to you for quite a bit during this. You can see that I was not in a rush and I had really no problems. I want to move this over. Let's go back and look at the boiler. Okay, and then on the boiler, this temperature, you have to be above 100 C. So you know, this was 30 minutes. This would start probably producing steam about 40-45 minutes. And in real life, as soon as I saw any steam coming out of the vent, if it hasn't been an hour, what do? You shut the fire off. You wait until the hour time period is up, and then you light off again. And again, once that hour's up and you are producing steam, as soon as you have steam coming out the vent, the air cock, you can close it. As soon as I had steam and no water coming out of this drain, I would also close it. But again, with 30 minutes, that would be for the next watch. All right, I hope that this has been informative and that it helps you be successful in your testing. I'll see you in class. Thank you.